See Standard 10th Maths Chapter 7 Mensuration Exercise 7.3 Sum number. A vessel is in the form of a hemispherical bowl mounted by a hollow cylinder. The diameter is 14 cm and the height of the vessel is 13 cm. Find the capacity of the vessel. See here, they given the vessel. The design of this vessel is, first they mention hemispherical bowl mounted by a hollow cylinder. This hemisphere is mounted by the cylinder. So cylinder should be on the top of the hemisphere. That is very important one. So here two figures you have. One is hemisphere and the other one is cylinder. See, the diameter is 14 centimeter. Here the diameter is same for hemisphere and also the cylinder. Therefore, the radius is same for both the hemisphere and the cylinder. Is half of this 14 is 7 centimeter. The next one, height of the vessel is 13 centimeter. Height is started from the cylinder here and the base of this hemisphere. The total height is given here for you, 13 centimeter. 13 centimeter. So this 13 centimeter includes the height of the hemisphere, that is already mentioned here, 7. The radius is same everywhere. So that is the height of this hemisphere. So 13 minus 7 is equal to 6. 13 minus 7 is equal to 6 centimeter is the height of the cylinder. So you have to find the capacity of the cylinder, that is the volume of this figure, the whole container. Okay. So let me first take the cylinder shape. Cylinder is diameter given 14 centimeter and the radius is half of this 7 centimeter. The height of the cylinder H is 6 centimeter. So first find the capacity, that is the volume. Volume of the cylinder is pi r square h cubic units. Keep pi as it is. R is 7 into 7 into 6. See, you multiply these two numbers. 7 sevens are 49. 49 into 6. 49 into 6 is 294 pi cubic centimeter. The units are in centimeter. Just keep as it is. Next you take hemisphere. Hemisphere radius is 7 centimeter. Only one units for this hemisphere. So volume is equal to formula 2 by 3 pi r cube. Cubic units. So 2 by 3 pi r is 7. 7 into 7 into 7. So this 7 into 7, 49. 49 into 3 is 7 is 343. Then multiply with 2, you are getting 686 divided by 3 pi. Okay. You have to find the capacity of the whole vessel. So total volume. So total volume is equal to volume of cylinder plus volume of hemisphere. Volume of hemisphere. So how much you are getting? Volume of the cylinder is 294 pi plus this hemisphere is 686 divided by 3 pi. Now add these two numbers. 3 is the LCM. So just here denominator no number here, so just you keep it as 1. So multiply this by 3. 3 4s are 12, carry over 1. 3 9s are 27, 28, 2 carry over 8, 882 pi plus just 3 goes here one time, write 686 pi. Now add these two numbers, you will get 8, then 16 carry over 1, 9, 10, 15, pi by 3. Now you substitute the value for pi. 1568 by 3 into 22 by 7. See here, 7 goes in this number, 1 7s are 7. Here in 15 it goes 2 times, carry over 1, again 16 2 times, remainder 2, 4 7s are 28. So 224 into 22 divided by 3. So you multiply these two numbers and divide by 3. So you multiply these two numbers, you will get 4928 divided by 3. So if you divide this number, you will get the answer 1642.67. So this is the volume of the vessel or capacity of the vessel is equal to 1642.67 centimeter cube. The unit is very important in mensuration, cube. The second question, Nathan, an engineering student, was asked to make a model shaped like a cylinder with the two cones attached at its two ends. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of the model. See, here the engineering student make a model shaped like a cylinder. The two cones attached at its ends. So with the base of the circle coincide with the base of the cone. Two cones attached with the cylinder. See, the diameter of the model is 3 cm. So the diameter of the circle base is 3 cm for cylinder and also for the cone. And its length is, that is the total length starting from this end of the cone, the vertex of the cone to this vertex of the cone. The total height is given for you as 12 cm. And the cone has a height of 2 cm. The height of the cone is here 2 cm. And also here the height of the cone is 2 cm. So what about the height of the cylinder? Here 2, here 2, 4 goes. From 12 I subtract 4. So I will get here 8 cm. So height of the cylinder is 8 cm. So now we will start the problem. Find the volume of the model. So the volume contains here volume of cylinder plus volume of two cones. First let me take cylinder. So diameter is given here. Diameter is given here 3 cm. So radius is half of this. 3 by 2, half of this. So that is 1.5 cm. And height of the cylinder, as I said, the total height minus the two heights of the cones, 2 times the heights of the cone. So 12 minus 4 is equal to 8 cm. Find the volume. So volume is equal to pi r squared h, cubic units. So Keep pi as it is. And r is here 3 by 2. So don't substitute the decimal. Just write 3 by 2. H is 8. Here 2 2s are 4. Here 4 2s are 8. So 3 3s are 9. 9 2s are 18 pi cubic centimeter. Next take cone. Cone. So the radius same, radius 3 by 2 centimeter. So diameter is 3 centimeters. So radius is 3 by 2. And what about the height of the cone? 2 centimeter. So volume, what is the volume of the formula? 1 by 3 pi r squared h cubic units. Here volume of 2 cones you have to find. Volume of 2 cones. So 2 into 1 by 3 into pi. Keep pi as it is. R is 3 by 2 into 3 by 2. See, what about the height? Height is 2. So here 1 3 1 3 cancel. Here 1 2 2 cancel. This 2 and this 2 cancel. So the remaining terms are 3 pi. Here just you have 3 pi. So total volume is equal to volume of cylinder plus volume of cone. So volume of cylinder, how much you have? 18 pi. 18 pi plus 3 pi plus 3 pi. So how much you will get? 21 pi. So 21 into pi value is 22 by 7. 7 here it goes 3 times. So 3 into 22. So that is equal to 66 centimeter cube. So volume of the model. It's a model. So volume of the model is equal to 66 centimeter cube. Thank you.